Sir,
The screen is visible, huh? Screen.
Okay, sir.
Okay. Okay. So good morning to one and all. Today we will discuss a topic on the remedial measures of multicollinearity. Multicollinearity. So last day we discussed about what is meant by multicollinearity and what are the causes and what are the consequences. So at the end of the previous class we discussed about what are the test, how we can identify, nothing but how we can detect the multicollinearity. So briefly, I'm going to throw that previous classes. See, the previous class we discussed about what is meant by multicollinearity. So as we know that what is meant by multicollinearity, can anybody can say that? So multicollinearity means that if there is a relationship between the two independent variables is called multicollinearity. If there is a covariance between the two independent variables. For example, if you write an equation y is equal to a plus b, y is equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus error term. So if there is any relationship between the independent variable, that is a x1 and x2. So that is called multicollinearity. So see, this is a multiple regression equation. If there is any relationship between the x1 and x2 or x2 and x3 or x3 and x4, so that is called multicollinearity. Multicollinearity. Okay, simple. If there is any correlation between two independent variables, or two or more than two, that is called multicollinearity. Sometimes they will ask there is a covariance between the two independent variables. Sometimes they will ask if the covariance in the sense correlation. Okay, don't confuse it. So as you know that if there is a covariance between x1 and x2, so there is no correlation, nothing but if r is equal to 0, nothing but covariance, nothing but correlation. The correlation between x1 and x2 is equal to 0, so there is no multicollinearity problem, nothing but if there is no relationship between the two independent variables, so we can conclude that there is no multicollinearity problem. There is no multicollinearity problem. For example, if the covariance between x1 and x2, it is called there is a multicollinearity problem, nothing but it may be minus, it may be plus. Okay, if there is any relationship between the two independent variables, it may be strong, it may be weak, it may be moderate. That is called multicollinearity problem. We are facing multicollinearity problem. For example, when you run that correlation matrix or something, so if you get if the correlation value between x1 and x2, that is equal to plus or minus 1, so what it is, so there is a perfect multicollinearity, nothing but we can conclude that there is a strong collinearity between the two independent variables. So as we studied that in correlation in the previous semester, if the r is equal, the correlation value is equal to +1, we can conclude there is a perfect and strong correlation between the independent variables. So here also same thing, but there is a relationship between the two variables. Here there is a only relationship between the independent variables. That is the difference between multicollinearity and correlation. And we discussed about that what are the causes. That is there is a tendency of economic, nothing but in our economics variable, most of the economic variable move together in over a period of time. And when you use the lagged values in your model also, you may get multicollinearity problem. And if there is any specification bias in your model, you will get multicollinearity problem. Then data collection method, which method you have adapted in order to gather the information. And then over determined model, for example, this it may happens when the model has more explanatory variables rather than number of observations. So in that cases you will get multicollinearity problem. So we discussed about that what are the consequences also we discussed, and at the same time we discussed about how we can detect the multicollinearity, nothing but how we can identify whether the particular model have been suffering from multicollinearity problem or not. So that is a case we can find out some of the tests are there. So on the basis of some test only, we can conclude empirically that this model have been suffering from particular things. So this is the first one, how we can detect the multicollinearity pairwise correlations. Pairwise nothing but we need to examine that pairwise correlation, nothing but x1 x2 or x2 and x3. Okay. Yeah. Then we can use the F test to examine the giant significance. Nothing but at the same time, in order to know that whether the particular model have been suffering from multicollinearity, we can use F test also. Then more and more important test, that is the third one, VIF, variance inflation factor. So this is the main test we can use. Most of the researchers or most of the scholars, they will use VIF values. And after using VIF value, they will use that Fahrenheit-Glaber test also. They can test. So there are in the Fahrenheit-Glaber test, there are three tests which we need to examine. That is the chi-square test, F test, and T test. Okay. So mainly most of the scholars will consider the VIF values. So on the base of VIF values only, the researchers, they will conclude that the particular model is suffering from multicollinearity or not. Okay. So these are the tests. Simple, you can remember. These are the tests which will come in the SET, NET, and other competitive exams. What are the tests of multicollinearity? Okay. So keep in mind, these are the 5 tests which are very important to know that whether the particular model is suffering from multicollinearity problem or not. Then after detect the multicollinearity, then so what is the remedial measures? So we identify that problems. We know that what are the causes and we know that what are the consequences. After consequences, we know that what is the detect, how we can detect. For example, if the model has been suffering from multicollinearity, how we can, what are the remedial measures? What are the remedial measures? So then today we will discuss, that is the main topic, that is the remedial measures of multicollinearity. Multicollinearity. So here, as you know that, for example, see, generally, if you are suffering from particular a fever, so what is the remedial measures? Nothing but we need to take some tablets. So at the same time, if you have a model, when you are running a multiple regression, if you are getting a multicollinearity problem, so you need to take some measurements to overcome from the multicollinearity problem. So in order to overcome from the multicollinearity problem only, we need to use some remedial measures. So certain there are some measures are there. So that are rule of thumb procedures. For example, on the basis of C, so these are the some remedial measures which we can overcome from the multicollinearity problem. The first one, a priori information. A priori information. Nothing but we need to know that whether we have followed a certain theoretical background of the model or not. For example, as you know that if you take into account a demand theory, what demand theory says, the demand is function of price and other factors. So if you take a price as a dependent variable, demand as an independent variable, so you can keep in mind that which variable is a dependent and which variable is a independent. Because sometimes when you are going to use such kind of models, you may get a multicollinearity problem. You may get multicollinearity problem. Then I will explain one by one also. So then next one is a combine the cross section and time series data. So can anybody can say that what is meant by cross section and what is meant by time series? Can anybody can say that, dear students? Manoj, Saikiran, and Monica, Srikanth, Saraswati. So cross section is nothing but see, when you collect information at a particular time period, that is called cross section. We can say simple surveys. There is a cross section, nothing but at a point of time, if you collect a data from the respondent, if at a particular time, that is called cross section data. For example, I want to know that what is your opinion on my class. If I collect today, that is called cross section data. Okay. What is time series data? If you gather information from over a period of time, from over a period of time, nothing but so from first year to at the last year, nothing but day by day, nothing but day to day. If I collect information or week by week, if I collect the information, that is called time series. Okay. So then next one, we need to combine the both cross section and time series. So when you combine these two types of data, what it calls? That is called pooled data or panel data. Pooled data or panel data. That is called pooled data and panel data. Then third one, dropping a variable and specification bias. When the particular model have been suffering from multicollinearity problem, simple we need to delete a unimportant variable. Simple we need to delete an unimportant variable from the model. For example, as I told you that when you take into account, there are number of variables. For example, if you take 4 independent variables, if there is any correlation between the x3 and x4 variables, what you can do, simple, uh, you need to delete which is unimportant. Okay, which is unimportant, nothing but which are not important variable if you consider. So you should be remove that variable from the model. Then fourth one, the transformation of variables. You need to transfer the variable, nothing but you need to change the variables from the different we can say the different form, nothing but we can say what we can say transform nothing but if you convert the data into the different values, nothing but log values or natural logarithm values, you may consider, you may transform your variables into the different things, nothing but if you take variable exchange rate, if you take gdp, the gdp value is different and exchange rate is value different. If you convert the data into the logarithms, natural logarithm or logarithm, so the data will get a uniform data, you will get a uniform data. Then if your model is suffering from multi-collinearity problem, you need to additional or new data, nothing but you need to add other data also, or you can increase the sample size also sometimes. Okay, so then the sixth one, the other methods of remedying multi-collinearity, nothing but there are other methods also there to remove the multi-collinearity problem. So, dear students, I will find out these points, 6 points. I will remember. The first one is the prior information. Please, second one is the combine the panel cross-section data and the time series data. So, if you combine this cross-section and time series data, it is called panel data. Panel data, PANEL, panel data, or pooled data, POOLED, pooled data. Okay. So, next third one is the dropping a variable from the model. Then fourth one is the transformation of the variable. Fifth one is the additional or new data. Simple, we need to add the data. Then sixth one is the other methods of remedying multicollinearity. There are other methods also there to remove the multicollinearity. So one by one we will discuss. So please unmute those Shivakumar and Kamatam. Yeah. See, as we discussed that there are first point is a priori information. So generally, when you take into account some of the tests in our economic theories, as I told you that demand theory. So as per demand theory only, we need to take the demand variable is a dependent variable. Other way, the price and income of the consumers and price of substitute goods and complementary goods to taste, we need to take the independent variables. So when you take into account dependent variable as a dependent variable as a independent variable, independent variable, and dependent variable, you may get some multi-collinearity problems. So in general, we will want to test the economic theories, a priori predictions rather than the simply impose them on data, for which they may not be true. For example, sometimes generally we need to test our economic theories also. For example, if you take the consumption is function of income. Okay, so where it can be applicable, that is you need to take into consider. For example, if you take your consumption depends on income. Okay, so I need to take your consumption is a dependent variable, income is a independent variable. For example, if you take into account street vendors, what they can do simple, how much they are spending and how much they are getting, that is income. For example, in the morning they will purchase the vegetables, and total day they will going to sell their products and they will get some income. Okay, so here the consumption is becomes a independent variable, their income is a independent variable. Sorry, dependent variable. The consumption is an independent variable. Their income is a dependent variable. Nothing but so on the basis of the situation only we need to apply the our models. So generally, how much they are spending, how much they are getting income. For example, if you take into account daily day-to-day business, what they can do simple, they can expend, they can do 500 rupees expenditure and how much they are getting income by out of spending 500 rupees. Okay. For example, they are spending 500 rupees. If they will get 600, their profit is 100. But if they spend 1000 rupees, they might have get 1200. Okay, so here the income is depends on what their consumption, nothing but how much they are spending in the morning and how much they get at the evening. So on the base of that theory, on the base of our empirical research, on the base of our objectives, we need to test or we need to apply which is dependent variable, which is independent variable. That is the a priori information. Is it clear, dear students?
Yes, sir.
Yeah. Then see, combining the cross section and time series. So as I told you that when you're combining the two data, cross section and time series, that is called panel data. Please remember this. When you're combining the time series data and cross section data, it is called panel data or pooled data. See, so a combination of cross section and time series data known as pooling data. Pooling the data or pooled data or panel data. Then suppose we want to study the demand for automobiles in the United States. So assume we have time series data on the number of cars sold and average price of the car and the consumer's income. For example, we will get some data from the automobile industries, how many sales of particular car, okay, and how much average price of the car. At the same time, if you collect the information from the respondent, nothing but those who purchase the car. So if you collect that particular income of the consumers, so that is called panel data. Okay. So at the same time, we are combining the time series. At the same time, we are collecting the consumers price, consumers income levels. So that is called combined pool data or panel data. Then third one, dropping a variables and specification bias. Dropping a variable and specification bias. See, when we can drop that variables, when we can drop the variables, when there is a multi-quality problem only we can drop the variables, or we can remove the variables, or simple we can delete the independent variables from the model. So this solution cannot can introduce specification bias. Why? Because in an effect to avoid the specification bias, researcher can introduce the multicollinearity. Hence, it would be appropriate to drop a variables. For example, if I want to take example, see a demand theory, for example. So demand is a function of price, income, price of complementary goods, and price of substitute goods test. If I take 5 independent variables, if I get any relationship between the independent variables, so what should I do? So which are more important variable, I will consider. Which are not which are not important variable, so simple I can remove. For example, if I want to know that substitute and complementary goods, if I take only one from substitute and complementary goods, maybe if you find a relation between the substitute goods and complementary goods prices, so you may get some correlation value. Nothing but there is a multi problem. Simple, you can remove which is unimportant. So how we can decide which is unimportant? I cannot say that, because so either researchers know nothing but those who are doing the research, so they know that which is dependent, which is very important variable, which is not very important variable. Okay, so for me it may be it is not an important variable. For you it may be important variable. In that case only the researchers himself or herself only should be they should be decide that which is which is important, which is not important. So which is not important, simple we can remove from the model, can remove from the model. And transformation of the variables, the fourth one is the transformation of the variable. So what it is, transformation of the variable, simple. So from the linear combination of the multicollinear variable, for example, when you run the linear combination of the multicollinear variable, simple we can transform the equation to the first differences or logs. Generally, what we can do, simple. Generally, first time we will take absolute values. Absolute value. For example, if you take GDP, exchange rate, and if you take another variables, for example, capital and other variable, so GDP value is different, exchange rate is different, and capital value is different. For example, the measurement, nothing but GDP measures in the crores, and exchange rate we can measure in terms of rupees, and capital we can measure in terms of thousands. Okay. For example, if you take into production, if you, it may be measures in terms of million tons or tons. So these are data is not a uniform. For example, GDP value is in the crores, exchange rate is in the rupees, and production the million tons. Okay, so other variables in the and different forms. So in order to maintain the uniformity, what you have to do, simple, we can convert the data into the log forms, logarithm forms. Okay, so that is called transformation of the variables. So after transforming the variables, if you get multicollinear problem, then what you have to do, simple, you can go through the First difference method. First difference method. What you have to do? Simple. Simple. We need to do difference. Nothing but first year value is 20, second year value is 18. Simple. You need to do the first difference. Nothing but 20 minus 18, 2. So that two values you should be taken to consider. That is a first difference model. Okay. So that is a transform the equation into the first difference or logs. Then additional new data. So simple, when the model is suffering from a multi-collinearity problem, simple, we need to add the data. What we have to do? Nothing but we need to extend our time data. Nothing but we need to extend our observation. For example, if you collect the 30 observations only, if you get the multi-collinearity problem, so what you have to do? Simple, you can increase the sample size. Nothing but you have to collect more information from the respondents, or if you collect information from the more observation, we can say the time. Nothing but what is the time period of the study. For example, if you collect the 30 years data, so if you need to collect more than 30 years, so then only you may not get multi-collinear problem. Simple, we need to increase our number of observations, whether it is a cross section, whether it is a time series, or if you combine the both data, cross section and time series, if you get the multi-collinear problem, then only after that also you can increase the observations. That is adding or new data. Then other methods of remedial multicollinearity. What are the other methods also there? See here, as I told you that increase the sample size, increase the sample size, and the issue of micro numerosity. That is a micro numerosity thing, but is a problem of n exceeding k. Nothing but see, it means that the problem of n not exceeding the k. Nothing but number of observation not exceeding the k. For example, k is a parameters. For example, see, so that is the case as I told you earlier. The number of independent variables should be less than the number of observations, or number of observations greater than number of parameters, or number of independent variables. The symptoms are similar to the issue of multicollinearity. There is a lack of variation in the independent variables. Sometimes there is a lack of variation in independent variables, so we will get a multicollinear problem. And the final thing that a solution to each problem is to increase the size sample size. So as I told you that previous thing that the solution to each problem, for example, when you are taking into account not only multicollinearity, if you take in the autocorrelation also, if you increase the sample size, so you may not get other such kind of problems. Okay, in research only, most of the people collect less time, nothing but less their period of the study is very less, so they may get multicollinear problem, autocorrelation problem. When you increase your time period or the observations, you may not get that such kind of problems in our research. So those who are using less time period of the study, so they may get multicollinear problem and autocorrelation problem also. Fine. See, this will solve the problem of micronumericity, but not necessarily the problem of multicollinearity. So when you increase the sample size, you will not get such kind of things such as multicollinear problem and autocorrelation. Then estimate the linear model with a double log models. So at the same time, as I told you that sometimes some people will use that the model a linear model, and sometimes we need to use a double log model. Nothing but at the two sides, dependent side and independent side, we need to convert the data into the both log forms. That is a double log model or the double log regression model. We can say that, or log regression model. We can say. So such a model may be theoretically applying since one is the estimating the velocities. So generally, when you are converting the log forms, so generally we can estimate the parameters in the form of elasticities. Elasticity. Simple. We can conclude that. So if the beta 1 is equal to 0.5, what it means that if 1% changes in independent variables, so it is going to nothing but, for example, sorry, if 1% change in x1 variables, so it is going to it leads to increase by 0.5% in independent, so dependent variable. So that we can see in the we can say, or we can show in the terms of percentage. So as we know that conclusion part, the so see, the multicollinearity is a statistical phenomenon which there is exist a perfect or exact relationship between the predicted variables. So sometimes see when there is a perfect, we can say a multicollinearity. So if you consider that in a Gujarati book, if you study, see they mentioned that most of the research papers also they mentioned that. So how much we consider the correlation values between the independent variables. So most of the people will say that if the correlation between the two variables, that is x1 and x2 or x2 and x3, if r is equal to more than 0.7, so simple, we can drop that relation, remove the unimportant variable, and if the correlation between the independent variables is less than 0.7, so we may consider. So it depends on the researcher also. Okay, so as per the experts only, they say that if the correlation value is 0.75, you cannot consider. So you can consider as a multicollinearity problem. So some people will say the 0.7 thumb rule. Some people will say 0.6 also. So most of the time, so you can follow thumb rule is 0.7 is approximately nothing but, so which we will follow most of the scholars suggestions. So that is the case. If you run a multiple regression, if r is equal to 0.75 or 0.7, you should be consider this particular model has been suffering from multicollinearity problem. Okay. Then when there is a perfect and exact relationship, it is difficult to come up with reliable estimates of their individual coefficients. For example, when there is a correlation, there is a perfect correlation between the independent variables. So it is very difficult to come up with a reliable estimate. Nothing but, so when there is a correlation between the independent variables, if you calculate the beta values, that is the betas, the coefficient values are parameter values. So if you conclude on the base of the values, so it is very difficult to say that it is whether it is a reliability or not. We will get the values, but we should know that whether the particular value is reliable or accurate. So that is the case we need to follow. And the presence of multicollinearity can cause a serious problem of with the estimation of the beta. See, when there is a perfect exact relationship between the independent variables, so there is a serious cause. There is a serious cause or serious problem with the estimation of the beta, that is the coefficient or parameters, and the interpretation also. For example, on the basis of interpretation, if you interpret that way, on the basis of beta value, if you interpret, so it may give the wrong conclusion to the other scholars, other people. And when the multicollinearity is present in the data, the ordinary OLS estimators are impressively estimated. Nothing but when there is a multicollinearity, so if you estimate that values, there is a imprecisely estimated. So it is very essential to detect and solve the issue of multicollinearity. So when you get the multicollinearity problem, it is very essential to detect. So simple, we need to know that how much how much there is a multicollinearity problem is there. Then, so on the base of the value only, we can solve that issues. For example, see, doctor, what they will check how much you have been suffering. For example, if the fever is certain level is more than, if you have been suffering from more than that level, simple, they will test some, they will take a sample of blood and they will test it on the base of test values. So simple, you will give the some medicines. So that is called, he is going to solve the issues. Okay. So here also in our model, as a social scientist, we can identify and how much the correlation between the two independent variables, and we need to solve the multicollinearity problem. So before estimating the parameters based on the fitted regression model. So before estimating only, we need to solve our problem. Then detection of multicollinearity can be done by examining the correlation matrix. As I told you that the main thing, correlation matrix and VAF values. So these are the two tests which we are very most of the scholars they can use, correlation matrix and VAF value. What is the variance inflation factor? Then, so whatever we discussed, that is the remedial measures, the measures which can help to us to solve the problem of multicollinearity. So whatever we discuss are 6 or 7 remedial measures which are very important to solve the problem of multicollinearity. I hope you understood, dear students. Hello.
Yes, sir.
Okay, sir. Okay.
Manoj, Saraswati, Srikanth,
Yes,
Sai
sir.
Kiran,
Yes,
Monica.
sir.
Okay, sir.
So thank you very much. Tomorrow I will take the class. Okay. So up to now we have completed 3 units, first and second and third unit. So tomorrow I'm going to start the 4th unit. So we have left only 2 units are there. Okay.
సార్ టుమారో ఒకవేళ ఇంటర్నల్స్ అంటున్నారు సార్ మేడం వాళ్ళు ఏమన్నా అడిగితే
Yeah, okay. Yeah, so if there's any internals exams is going to conduct, then I will not take the class. Okay, so after 18th
Okay.
or after 20 only I will take the class.
సార్ 18, 21, 23, 28 సేమ్ ఎగ్జామ్ సార్.
Yeah, okay, no problem, but yeah, it depends on the today we need to go the college, then we will decide. Okay,
ఓకే సార్.
so we will talk to the principal, then we will take the decision.
ఓకే
Okay, if the time permits also I will take today class also. Okay,
ఓకే సార్. థ్యాంక్ యూ.
so if the time permits only I will take the class. Okay, again in the afternoon. Okay.
ఓకే సార్.
Okay, thank you once again. I will thank you everyone. If you like this video, please share and subscribe to get more updates.